What's up, everyone? This is LeetCode 100, same tree. So given the roots of two binary trees, P and Q, write a function to check if they are the same or not. Two binary trees are considered the same if they are structurally identical and the nodes have the same value. So yeah, here for example, trees are structurally the same and each node has the same value, right? Here for example, they're not structurally identical, right? Because at this one, there's a left subtree, but not a right subtree. And at this other binary tree, there's no left subtree, but there is a right subtree, right? So they're not structurally identical, so you return false because they're not the same tree. Here, for example, structurally, these two trees are the same, but the actual values are not the same, right? When we go left, we get a 2 here and a 1 here, okay? So they need to be structurally identical, but also have the same value, okay? So the way we're going to solve this problem is just basically do it recursively. So basically, if P and Q do not exist, okay? That's a case where we return true, okay? So if P does not exist and Q does not exist, we return true, because that would be a case where, like, let's say we're at this 2 here and at this 2 here, and we go left and we go left. Neither of those have child nodes. That's a good thing. Or we go to the right and we go to the right. Neither of those have child nodes. That's great, right? So basically when P and Q, as we traverse this tree, if P and Q don't exist when we go a particular direction, that's a good sign, so we return true. Okay, now we also could have another case, which is basically if P does not exist or Q does not exist, that's where we return false, right? Because that would be like this one where we go right, and you see P does not exist, and we're at this one though, and we go right, and Q does exist, right? That'd be problematic. And we would never enter this if they both don't exist, because we handle that up here, right? So basically, if P and Q, if one of them exists but the other doesn't, we would enter this if statement, and we return false. So really what this is checking is, are they structurally identical, right, as we go along the trees, okay? Additionally though, another thing that might make this false is, of course, if the values are different. So if P and Q does exist, but their values are not the same, that's also another case where we return false, because remember, they have to be structurally identical, but the nodes also have to have the same value. So there are really two conditions to check if these trees are considered, the same or not, okay? And of course, as we do this, right, we're going to go along the tree. We're just going to recursively call this function on itself. So we're given an input of P and Q. So when we go left in P, we're going to go left in Q, right? At the same time, we need to do the same for the right subtree starting at the root node. So when we go right in, when we do P dot right, we need to do Q dot right. Okay. So yeah, that's how we check if the tree is structurally identical and also if the nodes have the same value. Okay. So basically, if P and Q don't exist, that's a good thing, right? We return true. Now, if P or Q doesn't exist, that means we only enter this, of course, when P exists, but Q doesn't, or when Q doesn't and P does, which means they're not structurally identical, or where the values, or where they both exist, but the values are not equal, right? And of course, that would violate our condition, or whether these trees are considered the same or not. So we return false in that case. And of course, we do this throughout the left subtree and the right subtree of starting at the root node, and we use this AND operator here. So if at some point, right, we find that it's not structurally identical or the nodes aren't the same, this whole thing would just return false, which is what we should expect. And so yeah, that's our solution. It's really not that difficult of a problem, at least conceptually, to understand like how we check stuff. So anyways, I hope this helped, and I'll see you in the next one.